My name is Paul Stahl. This is my assignment 5 for revisions over my unit of instruction, which was over law of sines and cosines. The demographic for my students was honors trigonometry students who are typically juniors and seniors in the school. This assignment's coming a little late. It's been a hectic last 2 weeks at school with the end of the semester approaching. We had some snow days thrown in there that kind of got the scheduling off. I chose to use backwards design for this unit of instruction, which was awesome because I was able to provide students with the standards, desired results, goals, and areas of the unit that they were to understand at the beginning, and we progressed through that sheet with them. As far as me identifying appropriate evidence of identified understanding, homework as a primary tool is definitely something that needs to be changed in the future. There were students that were absent when we graded an assignment, or students who were absent when the assignment was given to them. So the homework provides delayed evidence of understanding, whereas there's more formative assessment tools that I could incorporate into the unit that would give immediate feedback. In terms of organization, I want to change the way that I can identify each individual student's level of understanding. So I'd like to have some type of standards-based or goal-based spreadsheet identifying key areas of strength and weakness for each student as they align to the standards and goals and the desired results from phase 1 of backwards design. In terms of complex real-world and authentic application, this is where this unit has a lot of power, because law of sines and law of cosines is used to solve non-right triangles. Any polygon or shape that we see can be split into triangles. So it's definitely applicable to the real world. One thing that I found during this unit is that less teaching provides students more opportunity to explore and discover. One of the activities that we did, I showed the students a picture of the Pentagon building in Washington, D.C. We had just done one example, quick introduction to area of a triangle, and then I had them find the area of the roof of the Pentagon by subtracting the outside edge of the Pentagon from the inside courtyard. During that activity, I had 100% engagement from the students. They were really intrigued to tackle this challenging question, and they came in the next day and were asking about it and what the right answer was. It was really difficult for me to kind of sit back and not tell them how to do it or give them the answer. So one thing that I need to do for future years is find more of those authentic activities that pushes advanced students to challenge themselves while still being accessible to the struggling learners. So that's one big change that I want to do, is incorporate even more complex and real-world problems and kind of lessen the number of examples and let the students really explore and discover these formulas. As I discussed earlier, there's definitely a need for more formative assessment tools. I want students to be writing more, explaining their thinking, teaching other students, and journaling. So that's something that I'm going to incorporate in next year's unit. I have not completed the summative assessment or the performance event, so I can't speak to how those would be changed yet. Last is student self-assessment and reflections. Like I said, I gave them the desired results on day 1, and we've been constantly referring back to that each day to see what we have learned and how that meets our goals. They've been discussing it with their classmates and adding little notes to it, but I want to incorporate a more intensive writing session so that they can self-reflect better. And then I do want to have them come full circle and look for the enduring understandings. How has them learning the law of sines and law of cosines broadened their horizons in terms of being able to solve any type of problem? Before, they were limited with Pythagorean theorem or SOHCAHTOA basic trigonometry that can only be used for right triangles. And so I want to see what they think about being able to solve anything.